All right, I'm all ready to go. Are we live? All right. Welcome to Tulsa Open Source Hardware. You yes. So Tulsa Open Source Hardware is a part of Techlahoma. At least we are. If I get the paperwork filled out again for the next year, so there's a good 50-50 chance there. We'll take bets afterwards as to whether or not I remember to do that. What is Techlahoma? Techlahoma is a nonprofit, volunteer-run organization that's puts on over 30 monthly meetings, 2 annual conferences, and sponsors free local events. Tulsa Web Devs and other meetings cost money for food and for other expenses, and we do this to support the grassroots tech community of Oklahoma. So you can learn more about Techlahoma at techlahoma.org. And there you can find out all the Techlahoma meetups. There's a Help Wanted board. And there's lots of ways you can support Techlahoma. You can support it through Amazon Smile. You can subscribe on Twitch. You can donate one time or monthly. What's the license plate thing? I don't.
Oh, this is brand new.
Oh yeah,
Yes.
just got
yeah.
license plates.
Yes,
Approved by the state.
Yep.
Are they
So-
approved now?
They are approved.
What is that? What
In
is
other words, you can go down to your local tag agency or through the Oklahoma
Convenient
tag
auto renewal
software.
system.
Yes. And you can order, you can pay the little, you know how there are plates for various things.
Okay.
State, whatever. Well, this one is for Techlahoma. It is a black background with the.
has the funny tech
So,
bowl?
It has our wonderful Tech Bison.
Gotcha.
So you may want to. It turns out.
All right.
It turns out I'm not talking loud enough to be heard over there.
That's
so,
cool. So
yes.
yeah. So go to a license plate. What they call
Tag
this?
agency.
Tag agency. Go to tag agency. Order a special license plate. It'll have the Techlahoma bowl or what is that? Bison. Bison. Yes. So
Wow.
all right. You can also ask your company to sponsor Techlahoma, and you can buy some merch from the Techlahoma store. So and then B&K Makerspace donates this space for us to meet. They offer memberships as well. So if you're joining us online, you should come down for the next meeting and check this place out because it's really, really awesome. They have general memberships for just coming and using the facility, but that you can also purchase space for yourself that's permanent. So if you ever wanted to have your own little square of a it's kind of like a giant garage space with other people that you can have a piece of,
An awesome air conditioner.
and an awesome air conditioner. Yes.
Kind
So-
of overpowered.
So the makerspace, for those who aren't aware, it is for making anything, right? So if it's not like I'm a big fan of I forget the other place it's called, the Fab Lab. We're all big fans of Fab Lab, but at the end of the day, Fab Lab is more geared towards younger kids and educational type stuff, and the makerspace is geared towards actually getting stuff done.
Also, at the end of the day, they're closed.
Yes, that's also true. At the end of the day, they're closed, and we're open as long as we have a member here. So, anyway, B&K Makerspace, it's a great place, and it's bkmakerspace.org. Is that what it
It's
is?
bk-makerspace.com.
bk-makerspace.com.
bkmakerspace.com is Brooklyn Makers.
Ah, not the Brooklyn one.
Yeah, not the Brooklyn.
Yeah. A lot of the stuff, a lot of the Techlahoma stuff is on the 36 degrees north calendar. I missed Thunder Plains. Oops. That's not good. And then on December 13 is the Techlahoma Christmas party. I don't know anything about it. I just know that we decided not to have a December meeting because it's Christmas and I didn't want to do one. Let's see here. So this says we're supposed to RSVP.
Yeah, I think they all, because there's limited space.
Gotcha. Where is this place?
Isn't it over at?
It's the brewery, isn't it?
Is it the same place we did last
I
year?
think it's the same place we did last year.
Okay. Yeah, there's some brewery down by downtown.
Yeah, party was
Um,
interesting. It was very full, but it was fun.
Let's see here.
Music was good. It's like live music.
I'm having trouble finding the actual name of the place.
I want to say it's like
Right-hand
Marshall.
side, Marshall
Yeah.
Brewing Company.
Marshall Brewing Company. There we go. 618 South Wheeling. So, and And then many thanks to Blixa for streaming this. And Blixa, what's the name of your Project Make It? I was gonna say Mr. Make It, but that's your handle. So thanks to Project Make It for streaming this today. So anyway, I think that's most of our business to take care of. The one other thing, as I said, we're not gonna have a meeting in December. We're gonna pick back up in January. Normally we meet on the third Wednesday. We met on the fourth Wednesday because the third Wednesday of this month there's a nice little holiday right after it. So we decided we'd do it today. So so we've got a lot of new people here. So let's just take a moment to all introduce ourselves. Sorry if you're online because or I guess you can shout out your own information if you're listening on YouTube.
We are paying attention to chat.
Yes. So I'm John. I work for a company called New Medio, and I do lots of computer programming, and I do electronics mostly as a hobby, but I also teach electronics to kids. So introduce yourself.
My name's Brant, and I have kind of a micro MSP here in Tulsa. I do small business IT work, anything from printer setup to firewalls and VPNs and
Awesome.
point-to-point wireless internet links, that type of stuff.
Cool.
Talk to me afterwards.
My name is Munzer. I'm doing my master's in ACE in the University of Oklahoma. I'm interested in embedded Linux, STM32, microcontrollers. This is my domain. I'm working as a GRA, so all my day is embedded system, C, Python. It's my work now.
Awesome.
Excellent.
Oh, sorry, I'm just sitting here paying attention to the stream. I'm Blixa. I run Project Make It. We do software development for small businesses, which right now includes a company that does crash log reading from large trucks and like maintenance equipment and stuff. So
Those aren't the fun kinds of crash logs.
they're very interesting.
Are there fun kinds of crash logs?
Well, when you get to go down to Florida and watch them crash buses into trucks.
Okay, that would be fun.
Yeah.
That would be fun.
I sadly didn't get to go to that. I did the back end system, so it's like, well, you kind of work with the stuff, but it's more about getting the data to
Yeah.
the decoders. So it's like, fine, I'll work on that instead of going down to Florida. I also wasn't like 100% on the project yet by then, so.
All right.
Um,
Moving on.
Patrick Forender, also a software developer, a hobbyist in making things and programming microcontrollers and stuff like that. And, like to do printing, like anything to do with making. I do a lot of sewing projects too. I'm all around maker.
How's your jacket?
Yeah, how's the jacket?
That jack looks awesome.
Why don't you bring it?
Serious?
Okay.
My name's Doug Pickler. I'm Doug Made on Instagram. I'm not a electronics guy really. I do woodworking and sheet metal work, and I'm a member here, so I'm just lurking.
Awesome.
My name's Philip Kin, co-owner of both B&K Makerspace and Burwanger & Kin LLC, which is a software engineering consulting company. We have pretty much one client, which is the person I used to work for, and now I have my own company. And I'm just contracting with them.
Nice. That's the way to do it.
Right? But I'm my own boss now.
Yeah.
Well, my name is Dante Blando. Most of you already know me. I now work at the Bank of Oklahoma, but my real thing is I do Linux boxes and my own version of retroputing, which is, well, I like the old stuff, and then I like to see what new stuff I can put into it and make it do other things. And but I also have other fascinations. Language is one of them. Also mass transit, highways, and the ever popular large collection of computers.
So mass transit and languages, does that mean you can curse at other drivers in any language you want?
I would, but we're streaming.
Keep it PG.
Yes.
My name is Mike
Michael Schibelbein. I'm the COO of Worldwide Tech Connections. We're a startup here in Tulsa. I actually live in Denver and commute down here every other week. So depends on the weeks and stuff whether I'll be here or not. We're premier integrators for language and translation services. So we have online for web conferences and stuff. We have real-time interpretation and translation services. But I'm also the CTO, not that it matters. We got about 15 people, but I have several patents. I have a master's degree in electronic engineering, robotics and artificial intelligence from San Jose. So I play with that, but I do a lot of things with AI and deep learning and stuff like that. So get to, and then one of my things was I was on BattleBots quite a few years ago, if you remember what all that was. So
Nice. BattleBots.
got to
That's
play on
awesome.
a lot of that stuff. So but I did get kicked off something about projectiles. But anyway, we won't go into that. So I have played everything from the microcontroller, and we were discussing my first CPU was a 68,000, clear up to the new boys where I get to play on a NVIDIA DGX2. For those of you that know what that is to drool over, and so I'll come and keep playing with you guys. So.
I'm Andy Chandler. My day job is a software developer at Williams. I work on the measurement side of life. It's a lot of just ETL type projects. I also mentor the James High School robotics team for FIRST Robotics. I've been doing that for 7-8 years now. I teach the programming side of it. So that's me.
I'm George Hug. I'm a hobbyist. Mainly mess around with microcontrollers now, and I also do kite aerial photography.
Cool.
Yes, that's right.
Oh, you had that balance thing that you brought last week.
Yes.
That was awesome.
That's my Picabay rig.
Now, one thing I forgot to bring, because a friend of mine gave me. Have you all heard of the HC11 microcontroller? I forget what it's not a it's an old one, but he had the HC05, which he gave it to me in its original box, which had a 5 1/4 floppy with it. So
Nice.
yeah. Anyway, I forgot to bring it though, but I thought it might be fun at some point
Yeah, I
to
want
tr-
to see that.
yeah
I
try to.
still gotta dig my punch card reader out.
That would, yeah. That'd be fun if we could find a computer that could read them. So today George is going to talk to us. You can come over here. I've got your links all showed up. The one thing that we have to do is that you can't play YouTube videos unless the stream's off. So you have to tell. Oh, did we have anyone from the internets say that? Okay, no one from the internets introduced themselves.
Still going.
So, okay, so you'll need to tell Blixa to pause the stream.
Ready? I just I sent an email to John asking the musical question. Does anybody have reflow capability here? And the answer I got back was probably not.
I believe I do. I have a hot air station. If that's
Okay.
what you're talking about.
Yeah. Okay. I'm not sure. I've been researching this a little bit since then, and I'm less enthusiastic about the idea than I was in the beginning. The question is whether you really need to do reflow stuff, because you're looking at having boards made, getting a stencil made, using solder paste that's not cheap and expires pretty quickly, and then all of the kind of difficulties of that. Now, my solution to this problem is called through-hole, and I just stay as far away from surface mount as I can, but increasingly, of course, fewer and fewer parts are available in reasonable size. But you can still order, resistors don't have to be 0402s, and so you can order things for the most part that you can still hand solder. I mean, even something like a TSSOP, which I think is 1/2 millimeter pitch, you can do that. Something called drag soldering. You load up the tip of your soldering iron with solder and just drag it along the pins, and it just picks up the right amount. So I'm not sure whether anybody really needs this. I mean, does the makerspace ever have a need for this? You do?
It depends what microcontroller or component you're getting at. Some of the microcontrollers, the good ones that are coming out, 32-bit ones, tend to be that. So you may want to mount them to, they make these nice little boards that convert them to a through-hole style.
Right.
You may have to actually do the,
I've been dealing with that because I had a backlog of stuff that I bought in Dallas, and I just hadn't had the chance to solder. And once I got my membership here, I just went through and put all the headers on everything. So
Yeah.
I've got
And-
an SIMD 32 chip or 21, this and that. They're all on boards, and then plug the rest of it in.
Yeah. If you're dealing with something that's just tiny and is only available that way, even to mount it on an adapter, you're still going to have to do something. Some things work fine, others don't. Like something like a QFN package, where the leads sort of come down and wrap underneath. You can't do that with a soldering iron. But a hot air gun, something like the Harbor Freight heat gun, which still works. The problem with that is, you just have no control over temperature profiles and so forth. So here's what I've found so far, and I don't know whether this would be of any interest to anybody, but you could, of course, can buy a reflow oven for hundreds of dollars that'll do a great job. Most people, if they're not doing production, if they're just doing prototypes and stuff, they will take a toaster oven from Kmart and spend hours and possibly hundreds of dollars converting it into a toaster, into a reflow oven. Yes.
The reflow sous vide.
It just one thing leads to another, and what I read online is that even after spending all that time and effort and money, you're not really sure what you're going to end up with. They have hot spots and cold spots, and the type of oven that everybody recommends has quartz heating elements. These are the large, sort of light-colored heating tubes, and they come on very quickly and turn off very quickly, which is the advantage that they have. But at the same time, you can just burn something up if you're not careful.
They don't have the make it and bake it oven anymore. Seems like a
Well,
5-watt bulb.
here's the other option. The other option is a hot plate or an electric skillet. Now, that's when I first heard of that, I thought, you got to be kidding. First of all, it's the wrong side of the board that you're heating up, but apparently, from what I've seen, a large part of the hobbyist population and prototyping population prefers hot plates because they provide more consistent results. You are less likely to destroy something, either the board itself or a part. They just heat up more evenly, and so that's a possibility. But finding a hot plate that doesn't also have cold spots and hot spots is not going to be easy. I had one video where they had ordered something from AliExpress, and it's $150, and it's designed for this. But even so, he was sitting there moving it around to try to find the right spot and all that kind of stuff, Here's the problem. Assuming you could find something that heats evenly, all of these mechanisms have lag. They have thermal mass, they have overshoot, and you know, you can buy what purport to be reflow controllers, which are Arduinos of one version or another, or maybe something like that. They range from about $30 up to $150. But I don't understand how they adjust for the different characteristics of different ovens. You know, most of them have PID controllers, which is a fancy way of saying, you know, something that's is designed for controlling things like this. But PID controllers have to be tuned for the right application, you know, for what you're using them for. And how the PID controller would guess at the, you know, the Hamilton Beach 2-element toaster oven, I don't understand that. I just don't understand that. There are loads of videos on YouTube, and most of them are not encouraging. They just aren't. You know, the guy will say, "Oh, this works great," and so forth, and then he ends up and he's got bridges over almost half of his pins, and it just so I guess I'm just kind of here to raise the question: is this something that the group wants to do, or not? And how much would we want to spend on it? And I mean, I had thought about doing it a little bit different way, and this is going to sound crazy, but suppose you had a hot plate, and you by the way, this is $7. This is a K-type thermocouple with its own display. If you had that attached to the board, then all you need to do is to make the profile the same as the solder paste manufacturer says it should be. Basically, you heat it up fairly slowly to a certain point that's below the melting point of the solder, and then you hold it there, what they call the soak phase, so that everything gets up to the same temperature, and then you ramp it up to the reflow stage, and then once it's reflowed, you ramp it back down pretty quickly. And the idea, there's a video on here from a guy in Switzerland who just takes a regular toaster oven and one of these, that model in fact, and reflows boards with no modifications to the toaster oven, no controller. He is the controller, in fact. He would sit there and look at the temperature and trying to, you know, shut the thermostat on and off on his toaster oven. And he claims this works fine, and it might. A little bit fancier version of that, I was thinking, would be you could have an Arduino driving a solid-state reflow relay, and you'd have kind of a pulse width modulation on the relay, except not rapidly, of course, but let's say that with the total period of 5 seconds, you would vary the duty cycle during that period, depending on what percentage power you wanted. And then since solid-state relays are supposed to switch only at 0 crossings, that would work a lot better than trying to mess with the thermostat. A lot fewer spikes and burned contacts and so forth. But you would still watch this device, the thermocouple. But you could have like a rotary encoder where you could adjust the duty cycle from 1 to 100. You know, you change the duty cycle by like 50 milliseconds per step, and you could pretty precisely control the temperature of whatever, whether it's the oven or a hot plate or anything like that. And so the controller wouldn't have any feedback. It would just be you messing with it. And then once you found something that worked, all you have to duplicate is the time. You could have just a table of, so many seconds at this duty cycle and then followed by so many seconds at this duty cycle. And if you have it do that automatically, it will reflow your board. But, you'd need some learning to get to that point where you know that you're following the cycle, the profile correctly.
Couldn't you also do a temperature feedback on them?
The question is, could you do a temperature feedback? That's what all the other controllers do.
Right.
I'm just not sure. I'm not sure they do better without knowing anything about the oven or the hot plate you're using than the human being would do watching it. Now, it does mean you have to sit there and, for 5 minutes and try to make it.
Because I think what you're describing is, it seems that what becomes interesting here is this is a research problem. That it's about breaking it down into the correct steps. We've already talked about the object that provides heat, how it's like solid fuel. It's on and off, still has phases. It might as well, it's not like a solid state thing because it's a solid fuel object. But that you also are dealing with how do you, the question of which pieces are worth automating. Because then it does sound like a two-person job to get through the reflow, one person to watch and one person possibly to grab. So all of us have an interest somehow in moving from our PTH work towards SMD just because of this shrink.
Yeah.
We want to do it, whether we like it or not, whether we have the eyes to do it. I'm sure I do. But that it brings in the question of what is it we could do for less than the multi-$100 device.
That's the thing.
And what's worth breaking down? What can we actually, what hasn't been
Now
broken down correctly?
you can use hot air, as you were saying,
Well, yeah, I've
but
got that.
but
That
you
works just fine.
but you're
There's
gonna.
already built circuit and programming that does this. It's the exact same problem that a 3D printer with a heated bed faces. They have an external, they use PWM to an external MOSFET, and they power the hot plate. And there's a temperature sensor right in the middle of the bed. If you wanted to, you could actually put multiples in the bed so that you could average it out or something of that nature. But this problem's been solved fairly inexpensively. A 3D printer board costs about $18, and then you hack around with the firmware to only use the part you care about. And
Sorry, I'm not trying to interrupt your
No,
thought,
I'm
but
good.
do print beds get up to the kind of temperatures you need for reflow? I know mine has a max temperature we're able.
no, I wasn't saying use a heat bed.
Oh, just use the controller.
The controller and the software algorithm's already there. It'd be a matter of using the higher temperature sensor, which the newer models actually do. The hot ends, they have to be able to get up.
Oh, right, the hot end.
Well, as I was saying, there are a variety of pre-made
Well, this would be a
controllers
hack together
for
thing.
this purpose.
Well, I know, but this would be a hack together thing, but I wager you could probably do the whole thing for under $100, and that's including buying probably a silicon heat pad that can get up to that kind of temperature.
I did actually look at, because I was looking at building a large 3D printer, that I did find some fairly large silicon heat pads that could get up to obscene
Because
temperatures.
they run
and
right off
were
the AC. They're
not
Yeah.
super expensive.
Well, one of the controllers that's available is $30, and it's in Malaysia. It's from an outfit called Rocket Scream, and they it has a little display on it. They originally started out as an Arduino. What do you call it that you add on top? Shield. But now they've done away with the Arduino, and they just got the Atmel processor on there and the actual parts. To that, you need to add a solid-state relay, K-type thermocouple, and I guess that's about it. So this can be done for under $100 as it is, if it produces the right profile for the oven you pick. Oh, that's the other thing you need is the oven, and that's where I'm just a little bit goosey about what your chances are that this will really work.
Well, I think you nailed the entire issue near the beginning of your talk of that PID loop.
Yes,
You
PID.
mentioned it generally is not, it That's exactly the problem that Whitney. It's the same problem that 3D printers went through for a while, where if you built your own, yeah, you had to tune it. Like
Well,
that's
it's the reason the Prusa's have an auto tune, because even from one Mark III to another, that
Now-
bed will
now-
perform differently.
Now there's one of these controllers. This is the $150 one that has a learning phase, and you push learn, and it starts from room temperature, and it turns on the device full power until it reaches 100 degrees centigrade. Then it turns it off. Then it follows what happens after that.
Yeah.
How much does it overshoot? How long? What's the slope, basically? And from that, apparently, it learns enough to get it right. But, you know, that's more money than I think we want to spend, you know.
What's nice,
that might be
though,
fun
is-
to build. And that I mean, because we've got a combination of software and hardware guys here. So
Yeah.
What's nice though is that Prusa Mark III logic that does that has the learning phase and does the same PID loop, is open source. You can go grab that controller logic and slap it on an Arduino today, and you have to wire it the same,
Well-
at least adjust some of the wiring, but it should do essentially the auto learn PID loop.
Yeah. A lot of these controllers have open source stuff on GitHub. I mean, this like the $30 one, you know, that's available. They even have the Gerber files. I mean, you can do your own, you know, but for $30, I mean,
Yeah, it's
you're not going to be, you're
$30.
not going to make money trying to do your own. So I don't know. I guess I'm just raising this as a potential project if we wanted. Now, there's one other thing that we would need to talk about at some point. Assuming the thing would be kept here, there would need to be a way for group members who are not B&K members to be able to get in and use it from time to time.
I'm sure we can figure something out.
Okay.
yeah, we could probably have like just a before meeting or an after meeting on the days that we do Tulsa open source hardware, that we could make it open or something like that.
Well, you know, you got some, you know, the problem is that there's time ahead of the reflow, because you've got to, you know, assuming even you have a stencil, you know, you still got pick and place that you've got to do, and that's going to take some time.
I've
So
never actually done that. I've only used mine. I fixed my fridge. I fixed I fixed a couple other things. A monitor power supply board with my. I basically wanted a really good soldering iron, and I got it for a Christmas present. I asked for this. It has the heat plate on it, has the forced air, and it has a nice soldering iron. It's only like a couple, $250 I think on Amazon.
Yeah.
But basically, it helps me deal with cold solder joints.
yeah,
Because I don't have to go try and tap a soldering iron to every single piece of solder on the thing. I just sort of blast the whole thing with hot air, wait until I start to see it, crinkle as it softens, and then I'm done. And I fixed a problem where the defrost mechanism stopped working on my door. I replaced the stupid heating element that's in there, figuring that was the problem. No, that wasn't the problem. So that was wasting money. So finally came down to the conclusion it's got to be the controller. Damn it. So I pulled the controller and said, well, we may be buying a new fridge after this, but
At least you tried. Boy,
and
you
it worked.
succeeded.
It's
That's
worked-
awesome.
it's
You
worked
saved
for
a
9 months.
fridge.
Yeah.
That's big.
in terms of ovens and stuff, the one that appears online more often than any is the Hamilton Beach 2-element oven, which is currently on sale for $20.
I think I've got everything on your tab somewhere. You can probably just click through the tabs and find
that-
stuff.
So would there be an advantage to
Also, that Word file at the bottom right is your Word file you gave me. You click right there.
So is there
You'll get the
an
Word file.
advantage
I don't
in the
know.
oven
I don't know what
to
you're
having
pointing
the
at.
resource only come from the top versus from the bottom, or do you want it so?
You know, the stuff the one that I had both,
That's the
but
Word
had
file
like
you
a
gave me.
switch
Okay.
to turn the bottom off. And I can't remember, the person who built it gave it to me, and can't remember why they had the bottom one you could turn off. I usually just left them both on and they worked fine. I don't know a lot about the like thermal mechanics involved in reflowing, but yeah. From all the ones I've seen have it on both the top and the bottom. Yeah.
So
for
this
a
is
few bucks.
this has one element above and one below. The next step would be 2 above and 2 below, which would let you do bigger boards in theory. But on the other hand, It's more space, slower to heat up, slower to cool down.
Yeah.
May have.
What's our most common use case, Would it be for setting up those adapters for like microprocessors to make them into a through hole?
If I were going to use a reflow oven, it would probably be no more than 2x4 boards, like 2" by 4" boards would be the big boards that I would work on. I just don't work on big boards.
I could think maybe if you weren't just using it to build those little adapters, I could think maybe 3" by 4.
Maybe, yeah.
Yeah.
And they make
That
really
should fit in there, I
small
would think.
kits too, reflow kits. Like they're pretty hilarious. They look like miniature pizza ovens or whatever.
Yeah.
This big.
Do they have a
and
light
little
bulb?
slot.
Tiny board in there.
No, but I mean, there are.
Easy bake oven?
Holly
I remember
Hobby's
seeing
still
a
in
hardware
That's what I
project,
want.
which
I
was
just
just like,
like-
here's our micro reflow oven. It was hilariously
No,
small.
kids-
That's actually kind of
Get
awesome. I
Easy
want one.
Bake Oven, can you adapt it to be a reflow oven?
So you just
No.
replace the entire heating mechanism.
Melt.
Yeah.
The
Still Hobby
Old
is.
is
You
old.
like to see her face, man.
Well, yeah, the oven
She's
would
the
melt.
angel
All
of
right.
It's awesome. Ooh, pizza.
anyway.
It's a dual use oven.
I'm
No,
not.
Do not cook food in your reflow oven. That is a pro tip.
I'm not sure. I'm not sure how wide a board this would do. I mean, you're directly below,
Does that violate
directly
our,
below the heating
our
element,
policy?
so the outsides are not going to be as warm as the,
Right.
you know.
Well, the other thing I've struggled with, just because I'd be interested in this just from the art, learning the art of doing surface mount soldering, because it's not just reflow, it's flow. I mean, if you can do it, if you can redo it, you can do it, right?
Right.
So I don't know if you call that reflow too, but I mean, it stands to reason.
I think you
Whatever
do.
Soldered before shouldn't be.
Yeah,
redo.
for whatever reason they still call it reflow. So.
But I've struggled because some of the boards that I've hit with the hot air guy, they have like plastic components. on
Yeah,
them.
and those melt
Those
fast.
melt pretty, yeah, like Ethernet ports and USB ports sometimes have a plastic
That's
component
the
in them.
And some
that's
are
the
just
key to that
low-bearing chromium.
that curve, right? You do that soak phase and get everything up, but where it's not going to soften the plastic, and then just jump over it.
Yeah, a lot of the original manufacturers, there's different processes where they have under solder flows that the board rolls through, and then they put the through hole after they do SMD.
Oh,
and then they put
so the appropriate thing would be to take off the melty bits
yeah,
first and then reflow it.
potentially. I mean, you have to read whatever spec sheets from the components they usually have for the temperature allowances, whatever for whatever.
Or just put on the metal Ethernet plug.
People put
Why
aluminum
can I not
foil,
select
other
that?
things they don't wanna
There it
reheat to.
Ah,
Okay, here's
It's not bad.
the hot plate.
I've got one of those.
I have one of those sitting around in storage.
I'm pretty sure it's that exact brand and model.
So here's the problem. You know, this looks great. There is a single coil of heating element right in the middle. And if your board doesn't kind of fit over that, you know, you're looking at 50 degrees difference, you know, from one edge to on YouTube, when they show this, the guy's sitting there moving the board around trying to find a warm spot, you know.
What's great to
Great way
see
to
those
burn
on
your
FLIR cameras, where you can actually see the heat profile, and
Yeah.
it's like this red circle, and everything else is black. Like there's no heat anywhere except
I'm
right
thinking
over
maybe
that.
we should be thinking about using gas heat and like a double boiler. Because
Yeah.
then you're transferring the energy into
Oh,
a big
Oh no,
fan.
no, this
Does somebody
this
have
this,
like a forge
this
on
is
it
a
out here?
this is a thing. Gas heat is a thing for this.
Toss it in for a couple minutes.
Now this one has more turns, and it's $8. You know.
So you buy two and you make a sandwich.
Well, here's speaking of buying two. This is what I was thinking. Instead of all this controller stuff, you use one of these to heat this using the temperature controller to heat this one up to 180 degrees, which is the soak phase, and you leave it there. And you have another one that you spent $8 for at 220 degrees, which is the reflow, and you just move it over
Swap 'em.
and then move it back whenever. I mean,
Just need a little
that
slot.
that would work.
This is
It's a little
DJSMD.
conveyor belt type thing, you know, where it's basically got
And by the
control
way,
in the middle.
what you could use as the top for this is a circular saw blade. Now that's steel, and it might warp.
I'm supposed to have the dumb ideas. Our rule.
This might work. I mean, you could have side by side. They could be preset. You could epoxy the setting so it can't be changed. You know, this is 180 and this is 220 and this is it.
It's somewhat important that you don't move the board, though, right? In between the two phases.
You mean while it's melted? You don't want to move the
Yeah,
board?
I think we want the board to be stationary.
Well, not necessarily. I mean,
So when you
people,
get a really fast
people,
conveyor belt that
what
shoots
happens,
out,
what you see online is that people pick the board up with tweezers immediately after it's reflowed and move it over to somewhere else. This is,
Feels like
you
a
see this
person
all the
just go
time.
flying.
It's like Evil Knievel.
It is, you know.
Wee Knievel.
I have a feeling that if we could find a good top for this one and buy two of them, that one at reflow and one at soak would do it,
So you're
and
saying
you
this
wouldn't
is
have to
two
control a
bottoms
damn thing.
and a
This
switch
is the
and a
right
top.
level of garage tech for me, so I'm in.
So I prefer to do the toaster oven personally, but that's
So the only thought I have on that is, you mentioned that they have thermal mass, well, and so does the circuit board. So the question I have is, you said just, leave it at that temperature, but like,
Well-
if you put the circuit board down, or even if the atmospheric temperature changes, that's gonna affect how
Mhm.
hot it gets,
Yeah.
potentially enough to cause an issue, right?
Well, yeah, I don't think you'd actually want to epoxy the setting. I think you'd want to set it
You've
on a
got,
given day,
you know,
but
you've got,
want a
you got,
box.
Right.
you know, for $7 you can see exactly what temperature it is.
Thermal mass is taken into account with the time, the curve time, right? Like that's what you have to take into account, all the parts and the curve time of each part, and you work out the math and figure out how long it should be at soak and how long it should be
wouldn't it
at reflow.
wouldn't it take forever to get up to a decent temperature for the board though, if you left it open air, wouldn't you have to?
Yeah, I mean,
Because
you'd almost
air has
have to
that
put a
problem
box
of being
around
a
it.
swirly bug.
But I mean, heck, it's not that expensive to slap on some bricks and, foil tape and get you 90% of the way there.
I was thinking you just get your pot lid that's about the right size.
Sure.
Just put it over the top.
Yeah, glass works, anything that will keep the heat in.
Well, the advantage of having fixed temperatures on these things, preheat them 20 minutes ahead of time, is that you don't have to control anything.
Yeah, but then you're still it's gonna change over time because your use of it. I mean, they're
Well, right. So for any
Well-
given flow, you'd set it, but you wouldn't necessarily keep that exact same setting over months. You might have to retune it every time
Yeah.
you use it. But that's still a minor amount.
But you're gonna preheat it to the temperatures you want,
you guys
right?
have me convinced. I'm gonna pay the money for the real thing.
How much is the real?
I need my fingers.
The next question I have
Not
is,
that.
Not much.
Now you can get a
Definitely.
on AliExpress
DIY's true. It's like
or eBay.
No,
You
at this
can,
point, it's not about money.
well, you can get an official commercial reflow oven that has two overhead quartz elements that has just miserable reviews for like $145.
So you go another 100 or so, you get a decent one.
Well, no, there's a list of five.
Edelbrock involved.
There's a list of there's a list of 5 modifications to the commercial oven that everybody has to make, including removing part of the insides where they've used masking tape to seal off the edges. Masking tape
This is why
at
you can
230
buy
at 220 degrees Celsius doesn't work well, you know.
Now you've
No,
got
there's
me
some good
wondering if
reflow
I've
ovens out
been
there
using
for
my,
the 100.
if I haven't really used the full potential of my reflow station, because I've used the soldering iron, I've used the hot air.
Right.
I've never really had a use for the heated bed, because it's like a mesh screen with the elements underneath it. I'm wondering if what I'm supposed to be doing, instead of just heating it up directly with the air start to finish, is if I'm supposed to be putting it on that temperature controlled bed, letting it preheat, and then I only have to hit it with the air for a brief amount of time.
Yeah, I
That
imagine
may
the
be.
for soaking, and then the air is actually for the active
So
reflow.
I may
It
have
depends on
already
what it
got
goes up to, you know.
It goes up to at least 600.
Okay, well.
Yes. You're covered.
so the other question I have on the idea though of using 2 units is, you mentioned we would need to build an enclosure. Would it work if you soak it and then pull it out and, in the process of moving it, you're gonna be cooling it?
That's part of
possibly
my
some-
concern too, is
Yeah.
that you'd have
Well,
to
if
seize
you-
up between the two.
If you had the circular saw blade on top of the first one and you had the part on that, if you just simply have a mechanism for moving that blade over to the other oven,
That's true.
you've got heat under, it's going to stay hot.
You're essentially
and it's just
using
gonna
the
go
thermal
on
mass of
Actually-
the steel to.
Yeah.
All you have to do is mount the two hot plates to a board. So if you can move the board and then you build a tiny, rack that just barely clears the top of the hot plate. And when you wanna switch plates, you don't move the board, you just slide it.
You just slide it,
Yeah,
yeah.
I like
yeah.
that idea because then
Yeah.
you're not moving the board around.
It'd be quicker and more reliable, I would think, and less temperature drop.
That might
Yeah.
be the lowest tech reflow. oven, honestly.
I don't know, because you could
Short of
build that.
actually sticking it over a campfire.
But you could take one of those old cam drive, 1970s cam drive turntables from a radio station and use its shifter for that because it's nice and dense.
There you
and
go.
you won't get any of the rattle, it'll absorb all of that. Yeah, I'm seeing it. I'm seeing it.
So can I ask some dumb questions?
Sure.
So why are you using coils instead of ceramic, which has a smoother, more uniform?
It's just what you can find at Walmart. I mean,
I mean, you
Yeah,
have.
but wait, at Walmart you can also find one of those ceramic heaters. I mean, we can take one of those.
That's what I'm asking
Yeah.
for.
Yeah.
Because you get a bit more.
Yeah, yeah.
You get a more uniform.
Can we search for one?
Yeah.
What do we got?
The other
Yeah,
thing is-
that's
that's a
question.
that's a
And
good
then
idea.
on the ceramic, because you can have a much faster increase and decrease in it. So, and what's the temperature differentiation between the settle state and the flash point?
it's about 40 degrees
Yeah, it's
for
not
for.
huge.
So I mean,
It's
if
40
you-
degrees
if you
centigrade
go to
for
surf
leaded.
And then back down with it, but you would get that peak, and I'm
Oh,
just
yeah.
asking.
Yeah.
Because I've used those space heaters when I lived in LA.
Well, then would there be any advantage to considering a radiant? You know those ones that aren't supposed to heat the air in between, they just heat the destination?
Well, now these quartz elements are kind of like that. They're not totally IRR, but they're mostly, I think.
Yeah.
You can't do this. You have to keep.
Well, and those
Really popular.
microwave oven ones, if you ever want to just really be stupid, if you take those out and hook them up to a large difference in voltage, you can actually melt steel with those. They will get hot enough. They'll turn white hot, and you can melt down steel into a puddle.
So you're saying 9/11 was an amount of radar range, Joe?
No, let's not.
Obviously, you guys never
PG.
never cooked turkeys on a ship.
What's that?
You don't know how we cook turkeys
Uh,
on board a ship.
there you go.
Well, I don't really have anything else to offer on this. I don't know whether this is worth doing or not, or
Oh, I
who.
think it's certainly worth doing several
Tell them
versions
we're
of
not
this.
on
I was gonna say, full track.
It's a competition,
Yeah.
not that kind of turkey.
Everybody make your own reflow oven, and we'll come back into a show.
No, but we have a toaster oven team and a ghetto team.
Garage tech. It's garage tech.
And now we're back to what this man knows how to do because he survived battle bots. What's
Okay,
the
no
solution?
projectiles.
I-
No
I-
projectiles.
I-
Just put kerosene,
I will
kerosene on
I will
wheels.
stipulate though, that his
Projectile
solution
reflow.
should be doable in a night.
Yeah, you literally could build that in like
Whereas
3 hours.
The toaster oven one, probably not.
No. Well, the main thing is I mean, if you really want to do it right, you want to follow the profile, because, if you heat up too fast or too slow, things go wrong with the flux and all that, and same with cooling down at the end. If you go too fast, you're going to get thermal stress and cracks in the board and stuff.
Well, a lot of the ISPs have very specific heating profiles because they're fine as long as you heat them up this slow and then hold them for this long
Yeah.
before you jump them over.
Yeah.
Otherwise, they'll crack.
Yeah.
You'll end up with cracked
Yeah.
ICs, and you'll let go of their blue smoke, and then you're done.
Apparently, one of the
When you let the smoke out.
apparently one of the big problems.
We need to have a smoke recapturing device.
Oh, did you see the Amazon, or not Amazon, the Spark Fun April Fool's joke a few years ago? It was a blue smoke injector, and that came with a package of blue smoke. It was already sold out, though. They never actually sold any, obviously, but yeah, blue smoke injector. I want one.
I've always loved our light emitting resistor.
Yes.
They're what?
Light emitting resistor. What happens when
It's like a
you go?
smoke
It's, all you have to do is turn a resistor up real high, and they're all light emitting resistors.
They have the light emitting specs right on the package.
That's how fleas go to the side.
I have to say, one of the possibilities here is that the temperature controller will not maintain it at a fixed level. That it'll
I think
How
that's
could
a
this
given.
be?
all PIDs are sinusoidal to some
Yeah, but
extent.
this is
They're
not a
never
this is
uniform.
not a PID. This is a mechanical bimetal switch. Okay,
It's a Chevy Vega.
and it's not going to stay constant.
Yeah.
So you know, you may end up with some kind of controller or some kind of PWM anyway.
I think in almost every setup, you're going to end up with some sort of closed loop
I
or
think,
open loop.
yeah.
I think the thing to be aware of on those the mechanical ones is you're taking a mechanical system and putting it under a lot of stress with the
Yes.
heat. So unlike electronics, it probably will start to have a larger failure rate.
Well, and the drift isn't as measurable is the problem.
Right.
Now,
So
now one thing, because those devices, I mean, they do have an internal temperature sensor, like to keep it at a certain
Well-
level. It'll turn the heating element off.
mhm.
But I was
The
wondering if
mechanical
you
one
had,
will,
you know, depending on what you put over it, if it could even out the temperature.
My guess is that this will not maintain temperature at a fixed level. That it will cycle very substantially. I mean, in other words, there's a lot of hysteresis, I think, in this temperature controller.
I just wonder
And
if
it's
you-
just gonna go,
I just wonder if you could cover for that with whatever you put over it.
Well, that's.
I don't know.
If you're
The
using
saw
that
blade,
saw
I
blade,
think
it's going to absorb a ton of heat and have a ton of
It should
momentum.
smooth it out a bit.
It would just be something you'd have to experiment with to see
Yeah.
what happens.
If the saw blade is going to be a large thermal mass, that's also going to affect when you're spiking that temperature, because now you're going to have a nice smooth transition when you may not actually want that.
Well, and on the flip
Yeah.
side of that, you could have a small thermal mass under the thing and then use the blades as thermal masses above each of the heaters and swap those out.
Well, I don't know why you assume you have to keep these things right side up. I wasn't kidding when I said make a sandwich.
Yep.
You could take the higher temp one, and when you go to bring it in, you leave it on the lower temp one, and you have the other one inverted over the top for a short period of time.
Oh,
You
just
could.
bring it in and add the extra heat.
Oh, that's
to-
one other thing. The difference between toaster ovens and these and hot plates is that hot plates only let you put parts on one side, if that ever matters. Of course, frankly, I don't know how you'd do it in a toaster oven on the other side either. So,
I've
but
seen setups and it's not simple.
no.
You must have to rest on a tray or something.
They end up with essentially a jig that holds the parts this way and lets them rest.
Have you ever
on
seen
It-
how like a full-size professional machine does it? You basically have a template that holds the pieces in place, or you have to glue them, which is something you can do. You can get specifically it's component glue that you put on before you.
It's crazy glue for boards, right?
Yeah,
Yeah.
it's just got a higher
the
temperature
craggle.
resistance.
It's
The crackle?
You ever seen Lego Movie?
Oh, yes. The craggle.
Alright, well, I can show some stuff too. I got a couple little things. Old project we can just start to plug in.
Is there some
Yeah.
machine?
Computer? I don't think so.
I'm going to.
There's Pepsi.
Switch it over.
I think there's some. Someone has diet something.
There's
So
Patrick's gonna present some stuff,
presenting.
which I'm very excited about.
All right, because we were talking about reflow, I guess I'd start with my reflow adventure. Can people see that somewhat? Let's go to. So what I did a long time ago, I think this is like 2014, 15, is I made a little night light that wraps around an Apple charger brick and is powered actively by the charger brick. So there's with the front panel on, it's got a little PCB that's sort of perpendicular to it that sticks into the actual USB slot. So it doesn't actually use like a USB male connector or anything there. Do I have to speak? I can't see my screen, Blix. All right. Anyways, these are like really old things. That's how the layout board was laid out. And I had a little area for an NRF chip, which was like a little wireless chip. I was planning to have it wirelessly communicate with millions of these throughout my house to log temperature. I had a VCNL 4000 here, which is a light and proximity sensor that I used as a switch. So I had debouncing in the code. You put your hand in front of it, and this is where the USB little slot was. So this is like right on the front of it. So you use that as a switch, put your hand in front of it, switch modes. I had a little isolated temperature sensor here. Power, I think inverter was here, like a little 3-volt step down or something. There's the little USB insert. And then you can see here along the edge, I had the dot stars. This was the first time trying dot stars out. So wrap them around here, and then here you have some, Arduino, was it Atmel chip or something? I forget which one it was. Anyways, this is pretty much just like the Pro Mini. I just stole the schematic, relayed out everything, stole every component from one of them, except for like, I think I added also a current sensor resistor, shunt resistor here, as well as a little I2C current resistor. My motto with designing circuitry is like, oh, I don't know how any of this works, so I'm just going to use digital everything. So I2C all around. Like the temperature sensor was I2C, this was I2C, or the VCNL was. And yeah, so I have SPI breakout. And so what I did was, let's see if we can. So this is the before. This is related to our flowing discussion earlier. This is the before I flowed it. This is all pre-tinned. I didn't have any, was it solder beads or whatever paste? Yeah. So I just pre-tinned everything. And then I placed everything on top of some flux. Here's my reflow skillet. And on top of aluminum foil, so the aluminum foil keeps it, off the surface. And here it is, I think after everything reflowed, I can potentially...
And you didn't melt the LEDs.
And I didn't melt I watched it, and I just was very careful. I saw everything start seeding, and then once everything was done seeding, I turned off the heat. So my temperature...
Was it skillet?
Yes.
You just put it on your
No, it was, no, it's gas skillet, or it's gas stove with a skillet and then aluminum foil. So I'm going super hardcore, not even electric. This is
This is how we do things in Oklahoma.
yes.
They need a campfire.
Well, you're right. I didn't take it super hardcore.
Or a Dutch oven reflow.
Yeah. That would not work.
I literally spit my drink out.
Let's see here.
You got your top heating source with the coals you put on the lid.
Let's- So here it is, getting ready to start wrapping it around. Let's see here. So then here I was making the connection. So I just bent little quarter round, I think thick gauge wire of some sort, and just soldered along the vias. And then I think that all these blurry pictures, this does not look very bright on the screen here, but anyways, there's the proximity sensor, temperature sensor, it's here, a couple capacitors and the current stuff. And then here, yeah,
I know where that's
yeah, this is at the Fab Lab. So this was me experimenting with a case design. I reprinted this in translucent filament, and then it would disperse the light a little bit. Here's it all lit up here in the background. I was just testing out the connection. Here's inside of it. So the tolerances are very tight, so you can actually slip it on and off. I think I had some programmer pins here on the SPI or something that I was messing with. There it is, turned on, and I had it doing some wiping animation thing. With the VCNL, what I did is, since it's a light detecting and it's facing out the front, I used it to detect whether or not it was bright in the room, and it would dim or brighten the lights. So it would light or it would dim it down a little bit right when you turned off your lights. There's the front. Let's see. Don't really have much. Yeah. Anyways,
So what was the purpose of this?
it's a nightlight. It was supposed to be like a networked nightlight. Well, not really networked, but it was supposed to connect to like the NRF chips. They have their own proprietary mesh networking protocol of some sort. You can all connect them and then have a hub. And there was like a not internet thing. It's like a home automation thing that I was interested in at the time exploring, but I didn't end up exploring it much.
Sounds really familiar.
Yeah. But anyways, this was mostly like me trying to learn Eagle and what have you. But yes, so was my.
Really nice.
Well, thank you. My reflow adventure. Here's my current, hopefully not abandoned project. I'm going to. My hope is to make a DIY cell phone that has a Raspberry Pi 0W in it, as well as use an e-ink display here. So the size of display I plan to use is this one, vertically. Hopefully I can have like your names and text on it and whatnot. So this is the wave share, whatnot. If you want to pass around and look at it.
Do you have links for where you got parts? Or did you
I can provide them if people are interested or whatever.
I am very interested.
This is all gonna be open source, so
So what are you gonna run for the operating system for the cell
it's probably just gonna be Raspbian, whatever default, the Debian based Linux for.
phone? I didn't know
If
you're
you
gonna
need
run
any help.
Android on the Pi or
No, probably not. I'm not an Android
can,
person.
But an e-ink screen isn't going to work out.
Yeah, I plan to do like a custom driver for the e-ink display and try to.
If you need any help with the actual operating system, like packaging and whatnot, that's something I've been working with for the past probably month now.
That's cool.
Apparently, I wasn't aware of this when starting, but apparently, like getting an actual packaged version of
That's the wrong thing.
Linux or Raspbian running on a Pi is far more complicated than people will lead you on to believe. If you're not straight up using Raspbian, like if you want to say, for instance, strip out systemd or build your own init, things just stop working left and right because you have to rebuild the kernel.
Yep.
And that, while possible, I've yet to see it work out very well.
So what
first
kind
time
of
around.
input are you gonna have on it?
So right now the goal is to keep it pretty minimal. Right now I just have one button thumb switch, which is this thing right here. Quickly mocked out. So actually I brought a little 3D print that I did, test print. This was a little shorter module that fits with this smaller ink display. Yeah, if people want to look at this as well. And so this is my like test fit. So I'm trying to keep it like iPhone X width, and it's probably just gonna be like a little, hopefully just a little bit thicker than that, an iPhone X.
Is that a touchscreen though, or
No, it's not a touchscreen.
how do
So-
you dial?
It's a very good question. It's a very good question. The point that what I want to try to do is create something that's very minimal, because every phone project that I see is very much like, oh, I'm gonna put tons and tons of buttons on this thing and tons of little dicky wikis everywhere.
I am really fascinated.
And that is a technical name for miscellaneous components. But anyways, so one of the other cool things that I'd like to explore is doing a custom capacitance touchscreen in this area. There's projects that exist right now, and there's this nice little IC that you can get that you essentially make like a grid in your PCB, and I think you have to have 4 layers and a couple different grids underneath it, and then you have some like control bars that are emitting some RF, and then you can put your finger above it, and it can detect Z as well as like touching and tapping and whatnot, all within the IC, and it'll communicates over SPI, I think, or something like that. So I'm gonna try to do that. I haven't ordered it yet, but they're called Fly Touch or some. Pymaroni does one. I forget what it's called. Skywriter is the one that they sell. They sell Raspberry Pi hats for that too, so you can get like little ones for the 0W or the regular big Raspberry Pis to experiment with. So I'm gonna get one of those. I'm gonna breadboard a lot of this, and what I just sort of did initially was like, hey, I know what type of components I want. I want to see if I can fit it in a size, somewhat reasonable size. Sorry, that's super small. And see if it all sort of will fit together. So that's usually, I go CAD first, and I'm like, is this reasonable? Can I shove all these components in this area? But yeah, I'll probably have like an on-off toggle or button or something on here. Have space in here for doing a couple layers of components. As you can see, there's a good amount of gap there, so I could probably like do some stack. There's also stackability on the Raspberry Pi. It's facing the direction where you normally mount stacks on top of it, or hats on top of the Raspberry Pi. So I plan to hopefully either put the cellular stack on there. So one of the things I got was this GSM little board hat. I was going to experiment with it. It's got the SIM 86 8, and from Adafruit I ordered the Sim 808, I think, or the 808. But it's 2G connectivity. Yeah, you can look at that. Ooh. But yeah, was I not holding it up high enough, Lixa?
I just couldn't see the thickness of the codes.
Yeah, and then here's me attempting to write to the display, and it's gibberish because I was not sending something properly. And here is the mock-ups case. Anyway, so that's what I've been doing last week or so. I'll probably shove some more components. I'm going to put like a slot in for a speaker, so the speaker can be sitting out the front, and then also a microphone down here somewhere. This is the battery as well. Probably just do a single cell. I'll probably in this area here find something either from Adafruit or whatever that's like a buck converter or something like that to boost and also charge it and whatnot, so I don't have to do any of that on board or whatever. But yeah, so this whole part here is a circuit board too that I'll probably run the traces for connecting a good amount of everything and what have you, anything that needs to be custom done. But yeah.
For those of us that are uneducated.
Educated. What, this? SolidWorks.
SoftWorks, okay.
Who makes SolidWorks? Is that Autodesk as well? Or?
Assault Systems? They're based in Germany, I think. Das Assault.
I'm addicted to Fusion 360s.
So one of the things I really like about using SolidWorks, or not only one, but like you got slicing capability. I'm sure most CAD software has that, so I can go in here and check clearances of things and what have you. And whoops, and what did I click? Oh, I just super zoomed. So you can check clearances around things and holes for components and whatnot. So fun extra credit stuff is going on right now. This is actually being 3D printed on my 3D printer right now. So the case is. So hopefully that'll finish up in a couple minutes, and then I can pop it off and be like, look, this is what rapid prototyping is.
Right. Started that before the meeting.
Yeah. So it's printing right now.
For various values of rapid.
Yeah.
It's certainly more rapid than sending it off to a factory and getting it back in 3
Yeah, I mean, it'd be cool if we could do custom PCBs and whatnot too, rapidly.
I was actually looking into, since I bought a resin printer, and then within about a week of each other, the bed cracked, and so it would leak, and then the Z head stopped working. But I have what apparently is a 2K LCD screen with a giant UV bulb under it. I'm like, that's how you do.
Yeah, you can only get down to somebody worked it out in the number of mil, and I'll have to look it up again. But it was actually fairly thick traces that are the minimum size you can get down, even with those 2K screens. But it's still pretty good especially for homemade PCBs. You can't get to like industrial quality, but it's good enough.
I mean, it's short of doing like BGAs, it's still usable. And even apparently the new BeagleBone chip that came out a little while ago has large enough ball spacing to fit it. So
I'll show you my other insanity project. So this here is headphones, and the idea I was having is they're from a video game called Splatoon. It's a kid's video game, third person shooter or whatever. Anyways, this is one of the headgear things you can get, and I was just like, okay, I'm gonna model this in 3D, and like this I spent way too much time on. I've 3D printed it once, and my plan was to potentially make a mold, and then like do a carbon fiber top bottom layer of this and whatnot. So I was trying to make it. But yeah, you can see here, this is the level of insanity I had to go through to get the intersections of all the points. And I created a bunch of 3D sketches that essentially like intersect every point where the thing, and in SolidWorks, it's insanely hard to vector a hole through something based on the intersection of points and whatnot. So essentially what I had to go do is make a point for every single intersection of these 3D sketches, and then put a custom drill hole design, because the drill hole's normal to the surface, and the surface is curved. So that's like the trick, to get like a little, essentially nice little divot in the surface. So the idea is LEDs would be underneath these holes, and then you'd have like nice little flowing patterns on it and whatnot.
That is cool.
And so it's designed to be sort of split along the edge here. So there's a little cut along the edge. And then there's an inner component too, I think it's somewhere. Show. Yeah. That rings around there, and there's like a little ridge that it sort of slots into. Anyways, I like CAD stuff. It's a lot of fun.
Yeah, we need to sit down and have a CAD talk one of these times. Just have somebody go through their favorite CAD program. Maybe have a couple of them for the different options.
Yeah, and this is sized to fit my head only, so sorry. Anyways, at some point maybe I'll build it and then like be like, I don't play this video game anymore, but I'll wear this. Nintendo made it so you have to pay to use any of their online services, so I like stopped using it. Yeah. All right, cool. That's me. Anybody else got cool projects?
Well, this is
Okay, there you go.
All right. I've showed you this in several stages of development, but today I'm excited to announce we made it over the finish line. It's officially launched the new crash sensor for Specialized, and this is it's called Angie, and it stands for Angular something. It's basically detects movements of your head that are likely to cause injury or unconsciousness, and it will alert people on your phone to let them know where you are and what's occurred. And so anyway, I didn't get a lot of I got a lot of time with the hardware, but I didn't do a lot of actual hardware work. But I did a lot of the testing work for it, and I did a lot of the software. I was the assist man for the software team. So anyway, I was just really happy that we finally got this out the door. We've been working on it for a long time, and I think the initial batch that they're doing is 500,000 units. So anyway, so it's
a Tulsa startup right a while back.
yes, yeah. So this technically they bought the rights from a Tulsa company, and a friend of mine went to work there, and anyway, I think they've been working on this for about a year now to get this all up and running. It's now the app's in a bazillion languages. They've got a service you can purchase, and then they're working on a lot of new other features. For example, like if you haven't come back your ride in X number of hours, they'll also let people know, and other sorts of things. They have an app called Ride, where if you just for social riding. So if you're biking and you want to see who else is doing a ride locally, just a really easy way to link up with people. We're doing
Tinder for bicyclists.
yeah, that would be a
They already have that Strava.
I like that you just knew it off the top of your head.
It's been around for a while. I mean, it's not really a Tinder. It's the
Yes.
actual.
So anyway, I just want to since I've been yammering about this for a while, I just thought I'd let you all know that it is released. Today was the day they launched it, and as far as I know, we didn't have any launch hiccups. So woohoo! So anyway, yay! Anyone else?